Hello everyone, I'm Namita and I'm here with my teammates Ayush, Jimmy and Kamal from University of Connecticut to present our analysis on predicting telecom churn using JUMP. The data we have chosen is from industry that keeps us all connected, that is, the telecom and internet service industry. So, let's begin with a brief on the background. The US telecom industry continues to witness intense competition and low customer stickiness due to multiple reasons like lower cost, combo promotional offers, and service quality. So, to align to the main objective of preventing churn, telecom companies often use customer attrition analysis as their key business insights. This is due to the fact that cost of retaining an existing customer is far less than acquiring a new one. Moving on to the objective, the main goal here is to predict in advance the potential customers who may attrite and then, based on analysis of that data, recommend customized product strategies to business. We have followed the standard SEMA approach here. Now, let's get an overview of the dataset. It consists of total 7,043 rows of customers belonging to different demographics, single, with dependents, and seniors, and subscribing to different product offerings like internet service, phone line, streaming TV, streaming movies, and online security. There are about 20 independent variables, out of which 17 are categorical and 3 are continuous. The dependent target variable for classification is customer churn, and the churn rate for baseline model is around 26.5%. Goal is now to pre-process this data and model it for future analysis. That's it from my end. Over to you, Ayush.
Thanks, Namita. I'm Ayush. In this section, I'll be talking about the data exploration and pre-processing. In data exploration, we discovered interesting relationships. For instance, variables tenure, monthly charges, both were positively correlated to total charges. These three variables were analyzed using scatter plot matrix in JUMP, which validated the relationship. Moreover, by using explore missing values functionality, we observed that total charges column had 11 missing values. The missing values were taken care of as the total charges column was excluded due to multicollinearity. After observing the histograms of the variables using explore outlier functionality, we concluded that the dataset had no outliers. The variable customer ID had 7,043 unique values, which would not add any significance to the target variable. So customer ID was excluded. We were also able to find interesting patterns among the variables. Variables such as streaming TV and streaming movies convey the same information about the streaming behavior. These variables were grouped into a single column, streaming to, by using OR formula in JUMP. The same course of action was taken for the variables online backup and online security. We ran logistic regression and decision tree in JUMP to find out the important variables. From the effect summary, it was observed that tenure, contract type, monthly charges, streaming to, multiple line service, and payment method showed significant log worth and were important variables in determining the target. The effect summary table also helped us to narrow down our variable count to 12 statistically significant variables, which formed the basis for further modeling. We used value ordering functionality and moved yes of our target variable upwards. Finally, the data was split into training, validation, and test in 60-20-20 ratio using formula random method. Over to you now, Kamal.
Thanks, Ayush. I am Kamal. I will explain more about the different models built in JUMP using the dataset. We in total built 8 different types of model. On each type of model, we tried various input configuration and settings to improve the results of mainly sensitivity, as our target was to reduce the number of false negatives in the classification. JUMP is very user-friendly tool to redo the models by changing the configurations. It was easy to store the results whenever a new iteration of the model is done in JUMP and then compare the outputs in order to select the optimized model from each type. JUMP allowed us to even change the cutoff values from default 0.5 to others and observe the prediction results. This slide shows the results of selected model from 8 different type of models. First, as our target variable churn is categorical, we built logistic regression. Then we built decision tree, KNN, ensample models like bootstrap forest, boosted tree. Then we built machine learning models like neural networks. Jump allowed us to set the random seed in models like neural networks and KNN. This helped us to get the same outputs when needed. Then we built knife-based model. Jump allowed us to study the impact of various variables through prediction profiler. We can point and click and change the values in the range and see how it impacts the target variable. By changing the prediction profiler in knife base, we observed that increase in tenure period helps in reducing the churn rate. On the contrary, increase in monthly charges increases the churn rate. Finally, we did ensample of different combination of models to average and eliminate the shortcomings of individual models. We found that ensampling neural network and knife base has higher sensitivity among the ensample model. This ends the model description. Over to you, Jimmy.
Thank you, Kamal. In this section, we will be comparing the models and looking deeper dive into each model detail. The major parameters used to compare the models are cost of classification in dollars, sensitivity versus accuracy chart, lift ratio, and area under the curve values. The cost of misclassification details depicted on the right top corner of the slide. Cost of false positive and false negative determined using average monthly charges. The cost of false negative model predicted no churn for customer potentially leaving, calculate to $85, and cost of false negative at $14 after discounting 20% to accommodate additional benefits. The cost comparison chart clearly indicates that the naive base has the lowest cost. Moving on to total accuracy range chart, it is between 74 to 81%, not much variation in most of the models. And lift, a measure of probability to find a success record compared to baseline model, varies between 1.98 to 3.11. The AUC or ROC curve is another measure used to determine the strength of the model with different cutoff values. As chart indicates, all the models did equally well in this category. The sensitivity and accuracy chart measure the model's success to predict the customer churn accurately. The chart indicates two facts: how many customers that the model can correctly predict, two, how often the prediction be accurate. This measures used as the major parameter to decide the best performing model, and naive base did well in this category. Based on the various metrics and considering the cost of failed prediction of models, naive base came out as the best and parsimonious model to predict the customer churn for the given data set. It has lowest misclassification ratio, high sensitivity, and reasonably good total accuracy. If we discount some of its inherent drawbacks, such as lack of a statistical model to support, the model is completely data-driven and easily explainable. Moving on to the conclusions drawn. The significant variables in the dataset are contract and tenure of customer on roll. From modeling, we observe that chaining of customer is high for one, those without dependent in demography, two, those who pay high price for their phone services, low customer satisfaction rate on high-end services, three, customers stick to original single line phone service, easy switch over to competitors. So based on those findings, the recommendations are: one, targeted customer promotion focused on younger generation; two, push long-term contract with additional incentives; three, build a product line combo offer focusing customer needs. In conclusion, we used JUMP tool to do analysis and predictive models on limited data set. It is very effective and powerful to do those analysis. Please reach out to us if you have any further questions. Thank you.